Good morning, friends. Sorry for being late. Just a minute. Okay. Good morning, all of you. We are meeting after some long time. So now we'll be continuing further with where we had stopped last time. Okay. So let me share my screen. Okay. So I think we had stopped at our method that was Bayesian theorem. We had understood the Bayesian classification. So now we'll be continuing further with that. So Bayesian classifier we discussed. Today we'll be learning one new method that is today we'll be discussing two methods. So the first one is rule-based classification. So we'll be starting with rule-based classification. But before that, I would like to know: am I audible to all? I hope I am audible to all. Okay. Okay. Thank you. So let's continue. So in this case, actually, if we discuss about rule-based classification, then in that case, rule-based classification is an extension to decision tree. We have learned the method for creating decision tree. So in that case, we have again in case of decision tree we were having three algorithms. One was ID3, then C4.5, and lastly it was CART. So after that, using gain information gain ratio, and Gini index, we created the decision tree. After that, we studied Bayesian method. But this rule-based classification is an extension to the decision tree. That means, let me show you the decision tree which we were having. So in our case, this was the example of decision tree which we discussed. Now, actually, rule-based classification is nothing but the problem of if-then. If-then. So, if some condition is satisfied, then this is going to happen. That means, if age is middle-aged, then person buys a computer. So, in the same way, over here, what we will be learning is what we want to do is we need to define certain rules. What you can find out from this tree, it's very simple. If age is youth and student is yes, then buys computer. If age is middle aged, then buys computer. See, second rule. The first rule was if age is youth and student is yes, then buys computer. Rule 1. If age is middle aged, then yes, buys computer. So rule 2. If age is senior and credit rating is excellent, then buys computer. So rule 3. See, from this decision tree, we came upon with three rules. From this decision tree, we came up with three rules. The first one, youth and student, yes. Age, middle age, yes, rule 2. And age senior, credit rating excellent, then yes. So we got three rules, which says the person buys a computer. Now, can anyone state what are the rules that person does not buys a computer? What are the rules that person does not buys a computer? Can anyone state? There are two rules. Actually, there are two rules. If age is youth and he is not a student, then also not going to buy a computer. One thing. age is youth and student does not buy a computer. Fine. So rule 1 for not buying computer. Rule 1 for not buying computer. And rule 2 for not buying computer is age is senior and credit rating is fair, then also he doesn't buy a computer. See, the thing is what we define is important. We can define the rules for no, we can define the rules for yes. So if I say for yes, there are three rules over from this decision tree. So how we obtain the rules is from decision tree. So the if we go for rule based classification, then first step for us is to make the decision tree, and from that decision tree we will be finding the rules. So let us discuss the rules, because there is some parameter we need to check for rules. So let's go for that. So if I discuss about rule-based classification, then it is featured by building rules based on an object attribute. And rule-based classifier makes use of if-then rules. See, it is always going to use if this condition is satisfied, then execute something. We are very much clear about if-then. We are very much clear about if-then. See, we can express a rule in the form if condition, then conclusion. So let us consider rule 1. Now we need to go for mathematical concept. See, if then is a programming concept, very true, but it comes from maths, because everything behind computer is maths. So if then, so rule is represented in form of mathematics. We'll come to that later, but right now we are writing it as rule 1 states that if age equals to youth and student equals to yes, then buys computer equals to yes. Repeating again, this is an example of rule 1. If age is youth and student is yes, which we decided it from our decision tree, which we obtained it from our decision tree. So if age is youth and student is yes, then buys computer. So rule 1. Same way we were having other two rules. If age is middle age, then also buys computer. And if age is senior and credit rating is fair, then buys computer. So there are three rules for that. But in this, the if part what we write, the if part of the rule is termed as rule antecedent. See, these are the technical terms which you need to remember now. Generally, we speak out to be if this condition is satisfied, then you need to perform the statements. But actually, there are certain terms for it. If part of the rule is termed as rule antecedent or precondition. Then part of the rule is called rule consequent. So whenever I say if age equals to youth and student equals to yes, then this is your antecedent. This is your antecedent. Whereas then part, then buys computer equals to yes. So then part is termed as rule consequent or conclusion. So rule consequent. So what are the consequences we get when this condition is satisfied? That is rule consequent. And the antecedent if part, the antecedent part, the condition consists of one or more attribute tests. And these tests are logically ended. See, over here it is logically ended. We are learning this rule, how it is written. And is termed as logical attribute or logical condition. So this is one attribute, this is second attribute. So your age is first attribute, student is second attribute, which is logically ended over here. So same way we can have ORing also. If you remember the example of our professor, in case of the professor example, it was if rank equals to professor and experience greater than 6, then he is tenured. So over here, ending is not the only operator, logical operator. Ending as well as ORing, as well as not, that is negation. So we are having over here it is ended. So if age equals to youth and student equals to yes. And the consequent part consists of class prediction. See, always the consequent part, consequences what we get is always our class attribute. Is it fine? Are you all clear with this example? Then let us represent it in form of mathematics. See, this is mathematical form. This is English form. This is written in English like language, but over here it is written mathematically using some operators. Rule 1. If age equals to youth and student equals to yes. This is also termed as propositional language. This is also termed as propositional language. So if age equals to youth and student equals to yes, which implies bias computer equals to yes. So if the condition in a rule antecedent holds true for a given tuple, we say that the rule antecedent is satisfied and that rule covers the tuple. Now this is very important thing. This is very important thing. Just a minute, just a minute. Sorry for the interruption. Okay, so let us move further. So in this case, see, read this statement very carefully. The rule 1 is defined where age equals to youth and student equals to yes, which implies that bias computer equals to yes. So if the condition in a rule antecedent holds true, see, if I apply this and if the holds true for a given tuple, we say that the rule antecedent is satisfied and that rule covers the tuple. See, this term is very important. Rule covers the tuple. Rule covers the tuple. So we have this condition we are going to check for one tuple, one data tuple X. So over here, if this rule is satisfied, if the condition is true, if condition is true, and if this rule is satisfied, then we can say that the rule covers the tuple. So rule R can be accessed by its coverage and accuracy. So the question arises, what is coverage and what is accuracy? See, I already defined coverage. The rule covers the tuple. If the tuple is satisfied by this rule, then we can say that this rule covers the tuple. See, for the given decision tree which we discussed for the bias computer, we were having three rules. Rule 1, age youth and student yes. Rule 2, age middle aged. And rule 3, senior, age senior and credit rating fair. So there are three rules for bias computer years. But we need to find out what are the coverages. Say for example, if I am having some data tuple X, it satisfies rule 1. It satisfies rule 1. That means we can say that the data tuple X covers rule 1. See, the rule covers tuple. So we can say that the rule covers data tuple X. Let's see how. So given a tuple X from a class labeled dataset D, see we are having a training dataset D from which we are taking a single record, only single tuple. So let it covers the number of tuples by R. See, over here only one R1 we have taken, but if we see an example, then we are having three rules, R1, R2 and R3. So out of these three rules, which covers this tuple X, that we need to find out. And that becomes the cover. That becomes the coverage. So out of, see, just let me know, just tell me, if you take the same example, see, if you take this example, sorry, yes, if you take this example, can you tell me how many tuples are for rule 2? That means what is rule 2? Age equals to middle aged. That's it. How many are for rule 2? See, the tuple 1, tuple 2, tuple 3 and tuple 4. So there are 4 tuples which covers. There are 4, sorry, the rule 2, R2 is covered by 4 tuples. See, 1, 2, 3 and 4. So I can say the rule 2 covers these 4 tuples. Rule, see how I am speaking is very important. Please listen it very carefully. Rule 2 covers 4 tuples, 1, 2, 3 and 4. So question arises, what is the coverage? What is the coverage? How to calculate the coverage? Coverage is rule 2 covering the tuples divided by total number of tuples. See this. Coverage is defined as n covers divided by total number of tuples. Now n covers means number of tuples covered by that particular rule. Number of tuples covered by that particular rule, that becomes n covers divided by total number of tuples. So in our case, if I want to check for rule R2, coverage for R2, see, if I want to check coverage for R2 is given as 4 divided by 14. So that becomes my coverage. So I need to compute the coverage for all the rules. See, in this example, we were having 3 rules. So for that, I need to compute the coverage for all 3 rules. R1, R2, R3. So coverage of R1, coverage for R2 and coverage for R3. And from that coverage, we are also supposed to check accuracy. We are also supposed to check the accuracy of the unseen data. See, this is what we are talking of seen data, training data set. But what about accuracy? Accuracy is given as n correct. Say for example, some unseen data is given, and based on that unseen data, if my accuracy, how much accuracy we are getting, that is important. Say for example, if we get yes record for our actual rules defined, then that n correct divide by n covers. So that becomes our answer. So that becomes our accuracy. And that can be represented in terms of percentage. So multiplied by 100. So actually this is what is rule-based classification. We are not supposed to go into the example or any such detail of this algorithm because it is an extension for our decision tree. So if it is asked in the exam that give the rules for this particular example, then first of all you need to create the decision tree, and based on that you need to define the rules, and then only then you can find out the coverage and accuracy. Is it fine? In exam it was once asked that explain the rule-based classification. If you refer to the previous year papers, then you can check out the question asked is explain rule-based classification with example. So with example means you need to take that particular decision tree example and simply you need to state these are the rules derived from this. See, the one rule I defined, similarly you need to define the 2 rules and simply you need to state. And you need to define coverage and accuracy. Is it fine? All of you. Is it fine? Are you clear with this method? Good morning all. Is it fine? No? Okay, let me continue. Fine. Now we are starting up with the new method. The next method which we are supposed to discuss. As per our syllabus, the last method we are supposed to discuss, that is neural network. I don't know whether you have studied neural networks or not, but I'll give you some brief of neural networks also. Neural network method for classification is highly used. And with some modification to neural networks, we are getting various other methods. But neural network is a highly used method in classification. It is also termed as backpropagation method. It is also termed as backpropagation method. A backpropagation, a neural network learning method. How it works, we'll discuss it. So started by psychologists and neurobiologists to develop and test computational analogs of neurons. See, neurons. Now neurons, if I talk of neural networks, that means we are what the structure is there within our brain. What our structure is there within our brains, how our brain is connected to all the organs through neurons, and how the neurons are activated. That concept is highly implemented in case of our computers. So actually neural network is a concept of advanced studies. But we are having one method related to neurons. neural network. So we are discussing it. Don't worry about that. It's not that much difficult what you are thinking or you might be thinking. So psychologists and neurobiologists have given this method. So which is analogous to neurons. A neural network. See, consider our human body, human brain. It is having a large network connected. Our brain is connected to all the parts of our body through the neuron. So the neural network is generated. So neural network is a set of connected inputs or output units. See, input or output units. If you consider it with a human being, then our brain can be input and output can be our any organ. So a set of connected input output units, same way we implement it in our case. So set of connected input output units where each connection has a weight associated with it. Now weight, now over here I am terming it to be weight. Now weight can be priority also. Weight can be priority also. So over here, but we will not be considering the word priority. We should not use it, but we should consider the term weight. So during the learning phase, the network learns by adjusting the weight. See, if I give you a very real-time example, say for example, you are learning a vehicle, you are learning to drive a vehicle, or else, let me give you another example. You are learning swimming. Say for example, you started learning swimming. So your mind will start learning from the day one. What you will learn from day one? How to walk in water. But on day two, what will try? Because by seeing you cannot learn. You need to try. You need to implement. And you need to give feedback to your brain that on day one I walked. On day two, I tried to slide. That means I took my legs from the land and I tried to slide, but I was not able to. I tried to slide. Fine. So day two, if I say. So what your mind gave the feedback on day two was that instead of walking, you start sliding. But you got one problem during day two, that you were not able to breathe. You were not able to breathe. So what feedback again you gave to your mind? That while sliding, I need to take out my mouth from the water and I need to breathe. So your feedback was to take out your head from water and you can breathe. So on the third day, what you learned? You learned to slide as well as you learned to breathe. But on the fourth day, you came to know that I am able to do these two things, but I am not able to glide more distance. I am not able to slide more distance. So what your mind thought, that your mind gave the feedback to you only, that now you are supposed to move your hands. So initially you started waving your legs, now you need to move your hands. So see, three process started based on your feedbacks. One, that you started gliding. Two, you started breathing. Three, you started moving your hands. Then on the next day onwards, day 5, you started all these three things. Now your target changes. That now I want to swim faster. I want to move. I want to move my distance. I want to cover my distance more. So you again give the feedback to your brain that move your hands faster, move your legs, glide faster. So same concept is used in neural networks. You would be giving the feedbacks to the network from output to input within some hidden layers. See, my brain is not connected directly to my legs. It is my neurons are passing through some other parts of my body also and then gets connected to my legs. You all are knowing, say for example, we have also heard that, say for example, there occurs some problem into a spinal cord, then it affects our left hand. Fine. So the neurons are getting connected through other organs also, are passing through other organs also. So the same way we are having layers of neurons. So we are having layers of inputs and outputs. Fine. I'll show you the diagram, don't worry. So how our brain works, similarly this neural networks works. Like say for example, if you are learning cooking, say if I talk of girls, they learn cooking. So during cooking, first time when they started learning cooking, so they make some dishes. But first time they got some problem. So their mind was learned from back propagation, feedback, that this was my mistake. Next time I need to take care of this mistake. I need to solve this mistake. And you solve that mistake. So next time it doesn't happen. In classroom you don't follow this. In classroom you don't follow this. Your professor says, please don't disturb the class. You will disturb them double times. So the thing is, the neural networks are feedback networks. So based on the feedbacks, they train themselves. Based on feedback, they train themselves. And for that, they need to back propagate. For that, they need to back propagate. They need to get input back from the output. So it is also referred to as connectionist learning. Connectionist learning means various layers are connected with each other. Various neurons are connected with each other. That means, are these all biological neurons? No, they are not biological neurons. They are our computer algorithms, computer programs. They are not our biological neurons. Don't think like that way. So how neural network is a classifier if I discuss, then there are certain weaknesses of this. The first is long training time. It takes more time for training. Whereas in case of Bayesian, we are having fixed format. But this is more accurate than Bayesian, more accurate than decision tree. Requires a number of parameters typically best determined empirically. That is example, the network topology. See, I'll come to this point later. Network topology is to be designed. I'll come to this later. Then there is a poor interpretability. Difficult to interpret the symbolic meanings behind learn weights and of hidden units in the network. And strength of this neural network is high tolerance to noisy data. Say for example, if I'm having a large number of data in which noisy data is there, that means blank values are there, null values are there, then wrong data is there, misleading data. So it is a very high tolerance for that, instead of all other three methods. Ability to classify untrained patterns. See, in that case, it was having very less accuracy. I talked of accuracy. So ability to classify untrained patterns, well suited for continuous valued inputs and outputs, successfully on an array of real world data, that is handwritten letters. See, real world data, not computer data. Handwritten characters are there, handwritten letters are there. If I want to mine them, then neural networks are highly used. If I want to do character recognition, face recognition, neural networks are highly used. So algorithms are inherently parallel. And techniques have recently developed for the extraction of rules from trained neural networks. Say for example, I am having one neural network which is already trained. I can get the rules, I can extract the rules from that very easily. So these are the strengths of neural network. So instead of these three disadvantages of neural network, there are large advantages of neural network. So that's why they are being used into the world of data mining, spatial mining, then text mining, then face mining. Many things are going on. So how to define a network topology? See, I told you that we'll be discussing it later. So now we are discussing what is actually network topology. So if you decide the network topology, then we need to specify number of units. Hash means number. We need to specify number of units in the input layer, number of hidden layers if greater than 1, and if a number of units in each hidden layer, and number of units in the output layer. Sir, you are speaking this, but we are not getting anything. Don't worry, I'll show you the diagram after this, so it will be more clear with that. Then the next step what we need to do is we need to normalize input values for each attribute measured in the training tuples between 0 to 1. Say for example, I took the example that age is young, youth, senior and middle age. So I need to represent the corresponding values between 0 to 1 for them. I need to normalize. See, the word written is normalize the input values. Say, for example, age equals to youth is one value. Age equals to middle age, it is second value. And age equals to senior is third value. So I need to represent all these three values, all these three attribute values between value 0 to 1. That I need to define. When during the training tuples are to be measured. Then I need to give one input unit per domain value, each initialized to 0. So one input unit per domain value means attributes. How many attributes are there in our example? Age, income, student and credit rating. 4 inputs are there. So 4 input values I need to take separately and each is to be initialized with 0. Output. If for classification in more than 2 classes, 1 unit per class is issued. Say for example, in our example, we are having only one output, the by is computer. But say for example, if I want to check for 2 to 3 things, then I need to have one output unit per class. And once a network has been trained, its accuracy is unacceptable. Say for example, network is trained, but its accuracy is unacceptable, then I need to define another network topology, or I need to have different set of initial weights. See, these two changes I need to take care. If my trained network is unacceptable, so question arises, when can I say my network is trained? So when can I say my neural network is trained? Are you getting my point? So the question is, I need to check the accuracy, and if the accuracy is unacceptable, then I need to change my network topology, or I need to change the initial weights, what I suggested for that. Fine. So let's see the neural network. I'll come to this part later. Back propagation is a method. I'll come to this later, but this is your neural network. See, this is your neural network. Sir, how can you say? This is a multi-layer feed-forward neural network. See, there are many more types of neural networks are there, but out of which we will be taking multi-layer feed-forward. Feed-forward. See, this is what is your input layer. As you can see, this is your input layer, which is connected to more than one hidden layer. See, input layer, this is hidden layer. Over here, I have taken only one hidden layer. It can be more than one also. And I am having output layers. So this is output layer. See, understand this network carefully so that you will be able to learn the formula. Otherwise, you won't be able to know the formula. So this is your input layer of the neural network, where you will be giving the input values for the particular attribute. Say for example, this is your age attribute input, this is your income attribute input, this is your student attribute input, and this is your credit rating input. So you need to provide the values to them as an input. See, x1, x2, x3, x4 and so on till xn. Whatever number of inputs are there. So I told you earlier, see in this example I told you, one input unit per domain value. So this is one input unit per domain value. So one domain value age, second domain value income, third domain value credit rating, fourth domain value student. So this is your input layer where you will be giving your inputs. Sir, what is there in this block? Right now, I don't want to discuss in detail for this block. You just consider this to be a layer where you would be formulating some program. Now, if from this diagram you check out, there is one hidden layer in between. There is one hidden layer in between with three inputs 1, 2 and 3. These are the nodes. 3 input nodes in the hidden layer. Now this first unit is connected with this 1, 2 and 3. Similarly, second is also connected with this 3. Third is also connected. Fourth is also connected. Sir, is it compulsory to connect them all? No. This is what the diagram states. Now, connections are not necessary to be followed like this. This is a topology. You have studied the network. In network, you are having various topologies, bus topologies. So you're in various types of topologies. So from that, this concept comes over here. Topology, connection attributes. How you connect the layers. In this, the topology, I have connected x1 with this all three. But say for example, when I define the topology, at that time it may happen that the second may not be connected to the first hidden layer input. It may be connected to this only two. This one and this one. So it is the topology. That's why they had said that once the network has been trained, its accuracy is unacceptable. Repeat the training process with a different network topology. So different network topology means make the connections different. Instead of connecting with all three, connect with only one and check the result. So that is what they mean to say by this. And if you check it out carefully, this hidden layer is connected to the output layer. Hidden layer is connected to the output layer. There are two attributes in the output. It can be n attributes in the output. Are you getting this? So over here, this hidden layer is connected to both the outputs. Sir, is it necessary that both should be connected, both outputs should be connected with the hidden layer inputs? No, it is nowhere necessary to connect all. This is a general structure I am showing. This is a general structure which I am showing. Now just check it out. So once these are the things, defining a network topology, one input per domain value, output if for classification more than two classes, and I need to set the topologies. I need to connect them accordingly. Now see this diagram. What does this say? W1J. W1J means 1J. This is your OJ. See, repeating it again. This is your input layer. The output from this input layer is given as an input to this hidden layer. Output of this input layer is given to the input to this hidden layer. And output of this hidden layer is given as an input to this output layer. Sir, input, output, what you are speaking, we are not getting. See, from the diagram, it's very clear. The output of this input layer is given as an input to the hidden layer. And the output of this hidden layer is given as an input to the output layer, which processes it and gives you the actual output. Is it clear? So from this, see, if you are not clear, please put the question in the chat, huh? Please. So over here, if you check it very carefully, the W1J, see, W1J is the weight for this particular connection. W1J is the weight. I told you earlier, weight. W1J is the weight for node 1 at the input layer and node J at the output layer. So 1J, similarly 2J, similarly NJ, because N input is there, nth input connected to the Jth input. So nth output of input layer is connected to the Jth input of hidden layer. So WNJ, same way. What is this weight? What is this weight given? WJK means from the node J to node K, OK. So OJ connected to OK in the output layer, the weight is suggested as WJK. Now you should be clear with this particular weights. These are the inputs. Again, x1, x2, xi, xn. It is nothing but your array of inputs, or also it is termed as vector. So array of inputs. Same way we are having array of weights at all the layers. Over here only one hidden layer. It can be more than one hidden layer. And the output layer. So output, how many outputs are there in this diagram? 1 and 2. So I can have a vector, that is array of outputs, array of inputs, and array of weights. These three things I should have, based on which I can implement the theory, that is algorithm. So how this can be done? Let's see. See, basic theory I am teaching you. Read this. Actually, I had already taught. Iteratively process a set of training tuples and compare the network's prediction with actual target known value. Actual target known value means output. This is our target value. For each training tuple, the weights are modified. See, weights are modified. Weights are modified based on the error comparing with our actual output. See, I want some actual output over here, so I would be comparing with my actual output, and whatever the differences are there will be reflected to my weights. So for each training tuple, the weights are modified to minimize the mean squared error between network's prediction and the actual target value. See, when I started with giving input, I got some output which was not actual my output. So I trained my network again by changing the weights. At each point. And I trained it. Sir, till what time I need to train? Till I don't get the accuracy. Till I don't get the accuracy. Till that time I need to check. Fine. So over here, the next step, modifications are made in the backward direction from output layer through each hidden layer to the first hidden layer. Hence, it is termed as back propagation. See, over here, what we'll be doing? Over here, we got the output, but that output is not our actual output. So what we'll be doing? We'll be back propagating. We'll back propagate. We will not connect the output here directly to the input layer. No, we will back propagate. In back propagation, we will change the weights. Firstly, we'll change the weight for output to the last hidden layer. Then in between hidden layers, and then lastly to our input layer. Fine. So that is why it is termed as back propagation method. So lastly, what steps we need to perform? Initialize weights to a small random numbers associated with the biases. Sir, this we are not clear. I'll come to this, don't worry. Propagate the inputs forward by applying activation function. Sir, we didn't got, don't worry. Propagate the error by updating weights and biases. Sir, we don't get, don't worry. Terminating condition. We should have some terminating condition. Sir, we didn't got any of this thing. Okay, no worries. So for this thing, you are supposed to calculate certain formulas. And for that, the first formula is this. Input ij is equals to summation I for all x number of inputs, wij into oi plus theta j. Sir, what is wij? wij. What is wij? Weights. Then what is oi? Oi means output. OI means output. How many outputs are there? 1, 2. So OI means output. I need to consider them one by one. I need to implement it. Then what is theta j? Theta j is termed as bias values. Now these bias values are nothing but These bias values are always provided. When you start implementing neural network, the bias values are given to you, and based on which you are supposed to calculate the input ij. Then you need to compute, parallelly you need to compute OJ, output at unit number j, which is given as 1 upon 1 plus e raised to, that is exponential e raised to minus ij, minus ij. See, input which you calculated is taken as an input for that particular output unit. Why? See, I already told that output from this layer will be input for this hidden layer. That's why output from this layer will be input to this unit layer. So I need to take the output of this. On the contrary, this node is also going to give me the output. And for computing this output, I should have computed input. See, for having this output, I should have computed this input ij. So that's why the formula is given 1 plus e raised to minus ij. So first I need to compute input, then based on the input I need to compute output. Now why we are giving this summation weights? Because we are back propagating every time. So at that time we should implement this, because we need to change our input accordingly. That's why after back propagation, sir, this is input we had got, this is output we had got, but what our actual target is to train the weights. We need to train these weights. How to train these weights? Say for example, I was preparing a lemon juice for me. First time I was preparing and I prepared it, but when tasting, while tasting, while tasting the lemon juice, I came to know that I have not added the required amount of sugar. Repeating my point again, I prepared, I got the output. See, I got the output as a lemon juice. I am going to prepare lemon juice. I prepared it, but it is not as per my taste. So I need to find out what is the problem with that. What is not my actual output is not there. So what is the actual problem with that? Actual problem with that is that I have not added the sugar. And as I have not added the sugar with required amount, I will feedback, I'll give back propagate. I will back propagate that you have to add the required amount of sugar. See, I have already told, I have added sugar, but it was not as per required amount. So I need to differentiate it. Say for example, 100 gram sugar was, sorry, 2 teaspoon of sugar was required. 2 teaspoon of sugar was required, but instead of that I added only 1 teaspoon. So what now I will do? What I will now do, that I will now add the difference amount and not again 2 spoon. Then it will become 3 total teaspoons. So instead of that, I need to modify my weights. I need to modify my weights accordingly. So over here, for modifying the weights, first of all, I need to find out the error. See, I had obtained the difference, no? That actual expected was 2 teaspoon, but I have added only 1 teaspoon. So my difference comes out to be 1 teaspoon. So I need to find out the error remaining. So error in J unit is given as OJ into 1 minus OJ. That's output into 1 minus output. Summation K, error of K into weight J. See, previous errors are also to be computed. Say for example, I want to compute the error weight over here. I want to modify the weight over here. For modifying W1J, I should have modified WJK, and from that the errors which are back propagated is to be added over here. So that's why we are going with this formula, error in K unit into W of JK. So this is back propagated. Then, sir, what we are supposed to do? Now we are supposed to modify the weights. And for modifying the weights, we are having the formula L into error J into OI. Error J, what we computed over here, is given as an input over here and multiplied with the corresponding output of that particular unit. and multiplied with L. Now L is termed as learning rate. L is termed as learning rate, wherein this learning rate can be taken as some random value. Random value means you can take any value. You need to assume this value between 0 to 1. So thus you need to multiply all three, and that will give you the change in weight, delta Wij, which means change in weight, and that change in weight is added to our actual weight, which gives a new weight to you. And based on this, you need to change your bias also, theta value, theta bias. So delta theta j is given as learning rate L multiplied by error j. See, this is the theta. And theta j equals to theta j plus change in bias. The bias plus change in bias, which will give you a new bias. Is it fine? See, we are not supposed to calculate the formula. Example is given, but we are not supposed to calculate it. In examination, it is being asked, explain neural network based classification. This formulas you need to write, and along with this, you need to write one algorithm which implements this formulas. Algorithm which implements this formula. See, this is the algorithm I taken directly from the textbook. The algorithm starts with while terminating condition is not satisfied. See, what is the terminating condition? Till I don't get my satisfied output, till I don't get my actual output. But sometimes it may happen, I may not get output. I may not get output at all. I do not get desired output at all. So what do I need to do? So I should have some terminating condition. Otherwise, it will go into an infinite loop. So for each, there should be some terminating condition is satisfied. I need to perform for each training pupil in the data set D. I need to compute OJ, I need to compute IJ, I need to compute again back OJ, then error, then I need to compute the error for hidden layers. The same formula over here, TJ minus OJ, that means it is another value. But the error is given by this formula which we studied. Then for each weight, I need to modify my weight. So double delta I need to calculate, delta change in weight, which is added. Then I need to compute the bias, and that bias is to be added. See, all these previous formulas 1, 2, 3, 4 and 5 are added, are implemented for each training pupil. But sir, what is terminating condition? We have not discussed it. These are the terminating condition. So training stops when there are three conditions, again, three possibilities where we can implement this. The first one is change in weight is very small. This change in weight, Wij, is very small than the previous change. And that too, I need to specify the threshold value. If the threshold value I define it to be 0.1, then if the change in weight is less than 0.1, I need to stop. Sir, every time 0.1? No, it depends on your choice. Then the percentage of pupils misclassified in the previous epoch. Now, epoch is termed as iteration. It is also termed as iteration. In the previous epoch is below some threshold value. And lastly, a prescribed number of epochs has expired. I need to define, say for example, iteration I carried out. Say for example, I defined the 1000 iteration values. Then that 1000 iteration values, if it becomes 1001, then it should stop and change the network topology or change the data set accordingly or change the weights accordingly. Is it fine? So this is the algorithm which you need to remember. Okay, so fine. So today we stop here. This is the last method which we were supposed to discuss in classification. Next lecture we'll be starting up with the prediction methods. Fine. So today we stop here. Thank you all of you. Please put down your roll numbers into the chat so that
Sir, 71 I. Hello, sir.
Yes, please.
Sir, 71 roll number I disconnected for net.
71, you are present.
Yes, okay, thank you.